All right, Mr. Dueck, you've given us some equations, 4 equations, our constant accelerations equations. Where can we apply this? The answer is all over the place, like crazy. Here are 2 basic examples. The first one here, airport design. So now we're going to move from, Jake, me just in the last sheet that I gave you, just gave you all the variables laid out and said practice finding the equation, rearranging it. I'm going to assume that you're mastering that skill. If you haven't yet, do the homework. It'll come, trust me. Now we're going to see if we can pull the information from a application question. Example 1 says this. A jet airliner needs a takeoff velocity of 288 kilometers per hour in order to safely leave the ground. If the jet's engines can accelerate the jet forward at 3.5 meters per second squared, what's the minimum length of the runway? Okay. What are they asking me to find here? Length, distance. So we have to, now we're going to start to learn what words in English mean physics terms. How far? Distance. Length? Distance. Sometimes how long can be a distance, if I say how long was the runway. Sometimes how long can be a time. How long did it take? That one, that's a phrase that I try and avoid, but it's going to show up sometimes, so I included it sometimes. But we're going to learn certain words. Okay, so I'm going to write down, we'll use our DFIC approach. And now I go back and I start looking at numbers. I start looking for physics words. What's that 288? Chris, thank you, because whenever people say velocity, I get annoyed and I say, which one? Chris right away identified it. Which velocity? Now, I got a problem with this 288, though. What's my problem with this 288? Units. This is going to be by far your most common unit conversion because I lifted this, actually I Googled this this particular jet airliner, I can't remember which one I was looking at. It does need a takeoff velocity of 288 to take off, but it was in kilometers per hour and I was going to convert it. No. Sometimes they're going to give us numbers in kilometers per hour. We'll have to deal with that. So this time I'm going to write the units. You'll notice I wrote it as a proper fraction. And we're going to convert this. And then we're going to memorize a conversion shortcut. Because this one shows up so often, you've heard me, Olivia, say time and time again, don't memorize, don't memorize, don't memorize. This is one where I'm going to say, you know what? You don't have to, but you'll be doing this one often enough that it's worth memorizing the shortcut. From kilometers per hour, what do I want to end up in? So let's go from kilometers to meters. First of all, I want the kilometers on the bottom, meters on the top. What's my conversion factor? How many meters is how many kilometers? 1,000 is the same as 1 kilo. I also want to deal with hours. Where is hours right now? On the? Put it on the top. Do we know how many seconds? Do we remember in 1 hour? 1 hour. Okay. Now, put your pencils and calculators down for 1 second. If I look at this conversion factor, which I would do anytime I want to go from kilometers per hour to meters per second, what number is on top? Do you see it there somewhere? 1,000. What number is on the bottom? Here's the shortcut. If you want to, you can write this down. And in fact, I'm going to type it right here. To convert from kilometers per hour, meters per second, divide by 3.6. Can you see where the 3.6 came from? The fact that there's a 1,000 on the top and a 3,600 on the bottom, that's actually the same as having a single 3.6 on the bottom. Divide by 3.6. You can memorize that if you want to. It's the shortcut. I know in the homework a few times I am going to give you stuff in kilometers per hour because that's where I got the data. And that's what cars are measured in. So what is V final in meters per second? Sorry? 80 even? Okay. Keep reading. What else do I have? Someone say acceleration? How do I know? Okay, it's worth putting units together. So there's an acceleration of 3.5 meters per second squared. This is not enough. See, right now, I know 1, 2, 3 pieces of data. I know, well, D is what I want to find. I know VF, I know A. 2 to find 3 doesn't work. I need 3 to find 4. There must be something else that it expects me to reasonably figure out. And the answer is yeah. Yeah. What's VI? I've been on a plane. What's VI? I've been on a plane. They come to a stop always. And then they gun it. Right? So that one I'll expect you to reasonably assume. Yep. So I'm looking for an equation that has distance V final, A, and V initial in it. Which one? Olivia? Yeah, the squared. Okay, so VF squared, keep going, kiddo. Okay, there's my equation. Olivia, what are we trying to get by itself? This is also a tough one to deal with, but we can do it, we can do it. Ready? Olivia, my angel, what am I trying to get by itself? So it's over on the right side, and I see a 2 and an A, but deal with plussing and minusing first. What's this VI squared doing to the D mathematically? Adding, subtracting, multiplying, or dividing? How can I move it over? You are correct. I can write this equation as VF squared take away VI squared. And Jordan, my friend, that leaves me with a 2AD. What am I trying to get by itself, Jordan, my friend? 2A. What's the 2A doing to the D mathematically? Adding, subtracting, multiplying, or dividing? So how will I move it over? And it's two things. So the whole thing and underneath a big fraction, there's my new equation. That's not on your formula sheet. You can memorize that, I guess, Kylie, if you really feel, but you know what? It's really, trust me, worth mastering this ability to rewrite formulas. It'll save you a lot of work. Let's plug in numbers now. Chris, what did you say V final was? Careful, don't give me the kilometers per hour. 80 squared minus 0 squared, all divided by 2, 3.5. Chris, my friend, and all of you want to practice these on your calculators, because is there more than one number on the top? Is there more than one number on the bottom? I think brackets around the top, brackets around the bottom. Find out how you need to type this in. Hey, Jake, that's a nice calculator. I'm getting, you get 914.2, blah, blah. I guess 3 sig figs. 914? Just about a kilometer long, okay? See if you're not getting that, double check, but. Okay. Now, if you're designing this airport, Jordan, probably you'd build in, you'd double it for a safety margin. Okay, so you'd probably build your and in fact, probably instead of doubling it exactly to 1,828, you'd probably say as a nice round number, 2 kilometers long or something like that. Okay, look up. What if you put bigger engines on the airplane so that it can accelerate faster? If this number gets bigger on the bottom, if you divide by a bigger number, what happens to your distance? Which makes sense. Yeah, if you can accelerate faster, you wouldn't need as long a runway. What if you're doing the big new Airbuses or the big Boeing, is it the the latest one, which need a bigger launch velocity? What can you tell me about the length of your runway?
Bigger.
Gets bigger, okay? But we can see that by looking at this equation here, absolutely. Now, what if you don't come to a stop? I guess if you can kind of do a rolling start, you don't need as long a runway, but that's probably just as pretty dangerous with an airplane to not come to a full stop and not make sure everything's lined up. And I think only once have I had a rolling start where they turned the corner and gunned it right away without coming to a stop. And that was in Bellingham with a small airplane where I guess there was some room for error. But there you go, airport design. Did you get it okay? Yeah? Okay. Trying to show you some applications. Good habit to get into once you have found the final answer. Put a little box or something around it. A, it makes it easier for me to mark, but B, often you'll be using that answer to find something else, and it helps you find where you left it. Example 2. Accident investigation. So an RCMP officer is investigating a car crash. At the scene of the accident, there are skid marks that are 32.5 meters long. The driver of the car was speaking on a cell phone during the incident, and the cell phone digital record, you can hear the sound of the skid for 1.2 seconds. So the driver is saying, you can't charge me with speeding. The RCMP is investigating this and is going to try and decide whether or not they're taking this driver to court. If the speed limit on the road was 60 kilometers per hour, and the driver claims that he wasn't speeding, can the RCMP officer either prove that he was speeding, or can the driver prove that he wasn't? Okay? What's this question asking me to find? This one's a bit trickier. First of all, a velocity. Which velocity? Ah, by the way, what's V final? I know this. Gotta be 0, right? Car accident, 0. So it's asking me to find V initial. We're going to find V initial in meters per second. Then we'll convert it to kilometers per hour. And if it's bigger than 60, we charge him. If it's smaller than 60, he gets off. Okay? So let's write down what we're being asked to find. Okay. What else do we know? Yep. Ah, V initial. I'm sorry. Good gosh, Mark. Thank you. V initial equals question mark. Thank you, Mark. What else do we know? Okay, we know this. And I guess that would be true of any car crash. So anytime, by the way, beautiful physics in car accidents, terrible consequences, but beautiful physics, often I'll give you car accidents as an example. We'll assume cars come to rest. They're not still skidding somewhere. What else do I know? Oh, the skid distance was 32.5. And I guess the skid distance, that's his acceleration distance, because I think it's when he would start skid. Actually, he might have been decelerating for longer. He may have only been skidding for the final section. So really, when we find initial velocity, that's minimum initial velocity. He could have stopped before skidding. He could have decelerated before skidding. Okay? What else? I have 3 things. I can find a 4th. Is there an equation that has V initial, V final, D, and T in it? Yeah, what? Or on your sheet, yeah? Okay. What are we trying to find?
VI.
Let's get it by itself. By the way, are any of these 0?
Yeah, VF.
Okay, we could probably cancel out VF. In fact, really, Olivia, because VI was 0 last time, I probably could have gone, if I'd really been thinking about it. I didn't, but I could have. Whoa, what happened there? Went back to the other sheet. Come back. Lesson 6. We're back. So I won't. So we can do that, which I think modifies this equation into d equals 1/2 VI t. Yeah? What are we trying to get by itself? Okay. How? More specific. By what? And again, go one term at a time. So Chris, I'll pick on you since you volunteered, kiddo. I can ignore the 1. Yes? What's the 2 doing? Where is it? Top or bottom of a fraction? So it's dividing. How will I move it over? So I'm going to have this, I think, a 2, and the d just drops down like a domino. Yes, 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 yes. I want the VI to stay here. What else is next to the VI? How will I move that over? Yep. Okay. I guess that's a new equation that I could memorize when VF is 0. Forget it. I can derive it if I need to in one line. Not worth memorizing. Plug and chug. VI is going to be 2 times 32.5 divided by 1.2 in meters per second. What's the minimum speed this driver must have been going? Well, that's meters per second. Okay, that's 54.2. How do I go from meters per second to kilometers per hour? Well, how did I go from kilometers per hour to meters per second? What did we say up here? What about going the other way? Instead of dividing by 3.6, what? Okay. Almost certainly this, because this one here, there's no room for argument or error. And I made these numbers dramatic on purpose. Here, this driver would not have a leg to stand on with the RCMP. If this had been like 28 kilometers per second, and he'd been able to show that maybe he was doing 65 or 70 or even 75, he might say, well, that's what traffic was doing, right? I don't think traffic is doing 195 in a 60 zone, okay? He's going to be charged. He's going to pay a fine, possibly do jail time, or have his vehicle impounded. Pardon me? Actually, you'd be amazed what you can survive now. Car safety is pretty impressive. In fact, in about 2.5 months, we'll look at the physics behind what they've done with vehicles. We'll look at collisions. But we got to build up our physics skill first. Well, it all depends. He may have only bumped, you see, he may have skidded a long time and then only barely collided with something at the very end. And he may be saying, look, I barely dented that car. I couldn't have been going fast. There's no way I was speeding. See? Right? We don't know what the end result of the collision was. We don't even know. I could have said, suppose there was no collision. Suppose all you saw were the skid marks. You can still say, I know you had to have been speeding right there. You had to have been. Because again, this is minimum. You might have slowed down for a while without skidding. Probably not, because we're approaching how fast cars can go, most standard cars without modifications. But yeah, you're getting charged. Okay. So this is some of, if any of you go into the RCMP and go into traffic investigation, this will be some of the physics that they would be looking at. Measuring, if you've ever seen them on an accident scene, measuring skid marks and stuff like that, this is some of what they're doing. But another cool application is freefall. Freefall. Near the Earth, objects in a vacuum fall to the Earth with the same acceleration. You learned this number in Science 10. We use the letter G to represent the strength of the Earth's gravitational field. When you drop things in a vacuum near the Earth, what do they fall at? Now, we often say this. We include a negative to remind ourselves that it's downward. 9.8 meters per second squared. Negative 9.8 meters per second squared. Note, outside of a vacuum, air resistance can dramatically lower G, but we're going to ignore air resistance most of the time. So, for example, if I drop this, air resistance, that's not accelerating down at negative 9.8 meters per second squared. But if I drop this tennis ball, it's pretty aerodynamic. That was pretty close to negative 9.8 meters per second squared acceleration. Free fall. This gives us some cool applications. I don't know if you've ever stood next to a cliff and dropped something over safely as long as you knew nobody was below there. So let's suppose you drop a cannonball. Why a cannonball? I want to be able to ignore air resistance. So let's say a very round aerodynamic rock, if you want to go with that, is dropped from a cliff. And I got my watch on me and I time it. Hits the ground 5.6 seconds later. How high is the cliff? What's this question asking me to find? Okay, another word for distance is going to be height or how high. Okay, so D equals. Can all of you right now underline the word dropped? Because anytime I use the word dropped, you know something else. What's my initial velocity right now, this moment in time? Okay, I will never tell you that in the question. If I use the word dropped, I will expect you to say, I know VI is 0. There's one other thing. If I use the word dropped, you now automatically know the acceleration. This is the free fall acceleration that we just wrote in the blank right above. What do we accelerate? Negative 9.8. What else do I know? Oh, T is 5.6. So I'm looking for an equation that has D, V initial, A, and T in it. Which one? Oh. Keep going. It's always nice when what I'm trying to find is already by itself. Hey, Alex, why can I do that?
Because the initial velocity is 0.
Dropped. And that's why I said, I think it was with Zach, this is one that shows up an awful lot. Anytime you're dropping an object, by definition, VI is 0. So we're going to have D equals a half AT squared, 0.5, negative 9.8, 5.6 squared, Olivia, my angel. Yes? What do you get? Do you get a negative answer? Why? This is the universe saying, hey, did you end up above or below from where you started? Below, it's saying, I'm giving you the displacement. You ended up below from where you started. It fell negative 150. Technically, I should go to 2 sig figs. So I'm going to write this. Negative 153. Negative 153.664, and then I'll say that's really negative 150 meters. Now, technically, the word height itself is a scalar. You don't say, oh, the Golden Ears Mountains are negative 2.5 kilometers high. Nobody says that. So I'll include the negative, but if I was being really, really fussy, Olivia, I'd say it's 150 meters high, the cliff. But I like the fact that nature does come along and say, hey, I know you're ending up below from where you started from. Okay. What's B asking me to find? Which velocity? It's asking me to find the final. Now, I don't need to relist all my data since I put it right up here. I'm looking for an equation. It has to have V final in it. T, A, V, I. It could have D, but I'll try and avoid using D if I can, just in case, Zach, I got displacement wrong. I don't want to use it to find another wrong answer, unless I absolutely have to. Is there an equation that has V final, V initial, A, and T in it? Oh, and the VF is by itself already? Nice! Hey, why can't I go like that? Yeah, it won't always be, but dropped it will be. We'll eventually move on to what if it's not dropped, what if it's launched, but we'll get to that. Negative 9.8. T was 5.6. You get, oh, what's the negative telling me in my answer? It's telling me the velocity is downwards, okay? Later on, we'll actually throw things upwards from a cliff. That would be a positive velocity, and then calculate how long it takes to hit the ground. We can do all that. Then VI isn't 0. We'll launch. Negative 54.88. Or to 2 sig figs, negative 55 meters per second. It's going to hit the ground at about 55 meters per second. Or about 200 kilometers an hour. It's going pretty fast. You would not want to be hit by this. It would kill you. Even if you tried to catch it, it would almost certainly. So let's suppose instead of a cannonball, it was a baseball. Probably it would fracture a finger if you were catching it barehanded. Almost certainly. C. C. What's C asking me to find? Which one? Okay, it's asking me to find V final, but stuff has changed. Specifically, time has changed. What's the time they gave me this time? So I'm going to re-defic. I'm going to relist my data because things have changed now. Do I still know V initial? Yeah, it dropped. Do I still know A? Yeah. Negative 9.8. Do I know 3 things? Then I can find the 4th. In fact, it's going to be the same equation. Try this on your own. I think it's going to be VF equals VI plus AT. I'll freeze the screen. Try solving it yourself. Let's see if we get the same thing. You get negative 35.28 or negative 35 meters per second. Okay. D. I got right 35.28. Turn the page. D. Just carry on where we are here. What's D asking me to find? By the way, all of you said distance, and I'm fine with that, but actually it's going to calculate the displacement because it's going to give us negative or positive for what it's worth, right? Yeah, it's asking us to find D. Okay, what else do I know? Well, that 3.6, I definitely know T. Oh, I know this. Oh, and I know this. dropped. Okay. Try this one on your own. See if we get the same thing. You didn't tell us the equation. No, find the equation. I got an answer somewhere between negative 60 and negative 70. Closer to negative 60 than to negative 70. Barely. Yeah? Yeah? Yeah. E is negative 63.504, negative 64 meters, yes? What's the negative telling us again, Grant? Going down. Okay, but it's fallen 64 meters. Okay.
Oh, God.
Squared. E. I like E. I like E. I like E. E is a nice question. I like E. Why would I say that? You didn't hear me say it was going to be. You're just kind of students that notice when a teacher tends to emphasize certain things. Good for you. Good for you. E is tricky. E is saying how far does the ball fall during the 4th second of free fall. It's not saying how far does it fall after 4 seconds. It's how far does it fall during the 4th second. Any suggestions on how we can figure that out?
Find the distance of the 3rd and 4th second average.
Average, I gotta be, so we're gonna find the distance in the 3rd second and find the distance in the 4th second. And I think what we're actually, instead of average, we're gonna subtract. In other words, let's suppose in the 4th second, we've measured that you've fallen 100 meters, and in the 3rd second, I'm making these up, you've fallen 80 meters. How far did you fall during the 4th second? Okay, that's the first issue. The second issue is counting is going to make a difference. Put your pencil down for 1 second. And draw a little projectile. We start at time 0. There's the 1st second. Right here, that's the 1st second. Fall a little further. That's the 2nd second. Fall a little further. That's the 3rd second. Fall a little further. That's the 4th second. I think this is the second they were interested in. So I think what I'm going to do is I'm going to find, how's that for an abbreviation for distance after the 3rd second? I'm going to find distance or displacement after the 4th second. And then the answer is going to be that's going to give me that length, that little length right there. Is that okay? Pick your pencils up. Let's approach this here. So let's go little line down the middle, little line down the middle. 3 sections, but we'll need more room for the 1st and 2nd section than the 3rd section. We're going to find D3. We're going to find, does that work okay? D3, distance after 3 seconds. By the way, I think I said this the other day, but I'll say it again. Using subscripts, very handy to stay organized. And then Our answer is going to be over here. Is that okay, Jake? Yep. Okay. Let's go back to D3. What do we know? Well, you know what? I think for both of them, we know that. Yes? And for both of them, we know that. What? Negative 9.8. And I do know time for both of them, except it's going to be a different value for both of them. What's t for distance number 3? 3 seconds. That's why I called it D3. What's t for distance number 4? 4 seconds. That's why I called it D4. Is there an equation that has distance, velocity initial, a, and t in it? Which one?
D is equal to VIT.
Oh, I can go d equals VIT plus a half AT squared for both of these. I can cross out that for both of them because VI throw it 0, yes? Okay. So, let's make a little note. That's distance 3, that's distance 4, Mr. Dueck. Distance 3 is going to be a half negative 9.83 squared. Distance 4 is going to be a half negative 9.84 squared. A half times negative 9.8 times 3 squared. Negative 44.1. A half negative 9.84 squared. Negative 78.4. Final answer over here. Distance is going to be how far you fell after 4 seconds, take away how far you fell after 3 seconds. That should be how far you fell in that 4th second. Yeah? Negative 78.4, take away negative 44.1. How far do you fall in the 4th second? Negative 78.4, take away negative 44.1. What's that negative telling me? Oh yeah, we fell downwards. We fell downwards. Free fall. Put your pencils down for a second.